All right, this is part 3. Let's look at a few of these other quadratics to solve. So I have x squared plus 18x plus 81 equals 0. If you recognize, this is a perfect square, and that's a perfect square, 9 squared. So this is actually x plus 9 squared equals 0, and thus in this case, if I square root both sides, I get x plus 9 equals 0, and so x is just -9. So there's actually only one 0. If I have x squared equals 9, remember when you square root, you have to do the plus and minus. So this would equal -3 and +3. If I have x squared minus 3x equals 28, you want to move the 28 to the other side by subtracting it, because you want all the terms in that ax squared plus bx plus c equals 0 format. Now here I am going to factor x squared is x times x. 28, I think of 4 times 7, and 7 minus 4 would give me 3. The 3 is negative, so that needs to go on the larger value. So x equals -4 and x equals 7. So once again, I'm setting those factors both equal to 0. I'm skipping to 12, where it has something x plus 4 times x minus 12 equals 5x. The first thing I would do is FOIL this. So x squared minus 12x plus 4x, and then minus 48. So I get x squared minus 8x minus 48 equals 5x. Move the 5x to the other side. I'm going to, in fact, put it right there, because I want to get it in that format again, and collect like terms. Minus 48 equals 0, and now I have something that I can try to factor. X squared, x times x. 48, I actually thought of 8 times 6, but when you add or subtract, that's not going to give you -13. So then I looked at 16 and 3, because 16 times 3 is 48, and 16 minus 3 would give me -13. The negative is on the middle term, so it needs to go on the larger value. And now I have what I can solve, my x equals 16, or my x equals -3, when I set both of these factors equal to 0 and solve.